Hi guys, welcome to the 22nd part of this series of videos. I guess we probably should have been less ambitious and have several different parts to this, but well, we started, so now we'll finish it. This will probably be quite a few more parts, I'm afraid. Right, so the good news is, whilst you guys were away, I managed to solve the issues that we were having. Let's clock some time here. First, let's just have a quick look at what happened with the push. Wrong browser. This guy here. Let's have a quick look at the push that we just did. It looks healthy enough. We keep having timeouts and that sort of thing. And also Travis is going away soon. So we'll have to move to GitHub Actions at some point, but let's delay that until we really have to do something. So Travis seems to have compiled okay, and we did our little push here. And what was that push all about? Well, we solved the problems we were having with the helpers. So I tried to explain the difficulties we were having, and to be honest, part of it is just confusion from our side, really. So let's just do a recap of what we were talking about at the end of the last video. So pretty much everything you see inside of the model to text models, which are these guys, text.cpp and text.c#, the core of those is the text transforms. And archetypes are in effect a representation of a text transform. It's possible that we should really, now that I say that, I wonder if we should just call these text transforms. Well, I don't know. These are different perspectives over the same thing. And the archetypes are presenting you the physical perspective of the world. And it's basically a way to think of files as classes of files. And what the infrastructure of Dogen does is it creates a pipeline that takes you all the way from the codec model to the logical model to the physical model, which then corresponds to artifacts. So if you think of the typical use case for Dogen, you'd have some kind of logical model elements, like all of these guys here. And these logical model elements will then be projected over to physical space. And ultimately that projection will end up in one of these guys, an archetype. And the archetype binds to the logical model element. So for example, this guy here will bind to, well actually this is a bad example because it's actually a physical representation. But say for example, we take a class. The class, via configuration, will bind to the object. So for example, here you can see Dogen logical entities object. So this is binding to that. In the future this will just be the stereotype of that element, but we're not there yet. And this binding then results in the projection when we activate, when we instantiate the binding, we project that to the physical world into the form of a file. And what we've done is, very cleverly, maybe in quotes cleverly, we created a representation of all the infrastructure that is needed to build the archetypes themselves, which are these guys here. So we used the exact same principle, but we applied those to the meta elements of physical space. That's why you can see things like an archetype here, a facet, a backend, and so on. And so what's happening here is that you're defining an archetype that creates archetypes in effect. Where things become a bit confusing is when we try to do something like a helper. Because we didn't really want to create a helper that worked at the same level as an archetype, if you see what I mean. Well, or should I say, we did wanted to create one that works at the same level as the archetype. So the best way to visualize this is to imagine that every time you see one of these little squares here, that square then gets projected over 4 different files, regardless of what that square is. And the reason why is because that square is of type archetype, and the archetype binds to these 4 model to text transforms you see here. All of them all do that. And why? Well, it's because archetypes are in effect model to text transforms, which are generators, and the generators have a framework. And so they need these files in order to bind to the Dogen framework. And so helpers are no exception. And so it's easy to think of a helper just like you think of a class header. really, more than you think of an archetype. So when you take a class header, for example, here you have the template that generates the generator for the class helper, and in exactly the same way we have the generator here that generates the generator for the helper. And so anyway, going through all of this in our heads, we eventually came to a point where we managed to get all of this to work. We managed to get the diffs. I'll show you the diffs. The diffs are now rather what we want, which is in effect just the new helper versus helper, as you can see here. Although yes, this is basically just the helper name, and that's just the helper name, and there you go. So the diffs are now quite good. So this is our first step in getting rid of helpers, well, the old helpers. What we're going to do is we're going to remove the old helpers, and we're going to rename the new helpers to the old helpers. So in effect, what should happen is we should just see the deletion of the new helpers. They're just going to disappear. Everything else should be exactly the same. So what we'll do is we do that, well, perhaps in groups of helpers. I don't think we can do this one helper at a time, but don't want to take on too many of them. Of course, we will preserve a lot of the stuff of the old world, so we still have to initialize them, we still have some crazy traits and all that sort of stuff. We're not going to touch any of that. This is just step one. Step one will then enable us to get rid of the templates and the stitch files that we still have lying around. It will also enable us to get rid of a couple of transforms that are legacy, the stitch transform and the weld transform. And it will also enable us, if we want to clean up the templating model, because we have a number of fixes that are pending on the templating model that never went in because we still had the old legacy uses of the API, and really we just want to get rid of that. And probably also the thing we can do in terms of cleanup is we can finally start to get rid of a lot of the legacy keys that we still see lying around here. So that's one direction of refactoring you can take. Now, bear in mind that we are also in the middle of another refactor, which is the actual Formatables refactor that we're trying to get rid of. So I'm not sure if you're going to take on that initially. So I'll discuss the second refactor we need to do then. So once all of these guys are done, it's not actually dependency per se. I mean, we could leave this as it is, to be honest. The thing we're really interested in for our first refactor, or for the second refactor, according to my numbering here, the thing we're interested in is we're interested in a faithful description of the helpers, such that I can loop through the physical metamodel description of the helpers, and that is actually correct. Now, in order for that to be true, these names have to be fixed, and that's why I kind of contradict myself slightly here, and that's why we have to get rid of the legacy ones, just purely because we need the names to match. So what we'll do in this video, we're not going to have a lot of time. We're 8 minutes into it. We're probably going to have less than an hour for this video. We're going to try to do a few of these. We start with a key one, really. This is going to prove the theory. And then we just have to go through all these guys here. And the reason why this is not entirely trivial is because we need to copy the stitch template from the file system, and then we need to update the keys to the right incantations here, and then we need to make sure that we're referencing the right template in the Weld space, and also we need to make sure we got the right family. So this is not exactly the fastest thing we're going to ever do, but if we do a few, it'll be good, and then away we go. And then once we're done with that, we then have to see how many helpers we got in C#, which is good actually. We only have a couple, so that'll be pretty quick. And that's good, that's good. So that's the objective. Let's just get a few of these done then. So the very first thing we're going to do is we're just going to delete this guy, and then we're going to delete the word new, and then we're going to delete the word new, and we're going to also get the template out and make this match the new world. So I'm actually just going to do a search and replace in case we miss something. So now then, the new style helpers are now taking over the name of the legacy helpers, and well, just the one. So let's leave this guy here, and if we then just simply generate this guy, so that would do, and if we just do a convert over to JSON and an indent the JSON file. Now, if everything is gone according to plan, we should... okay, everything has not quite gone according to plan. Right, now the reason why everything is not quite gone according to plan is that there is still a rename. But that's alright, it's okay. It's not exactly the same file because it's following the new framework. But nonetheless, what we need to now do is we need to now locate the initializer for types. This probably means we need to do all of... Well, actually, let's see what it means. Let's have a look at initializer. Now, initializer will have somewhere a helper, where she is here. And then I just wonder if I can literally just register a transform. This may or may not work. Let's see what... So, why should this work? Well, we are implementing the same interface. So in theory, we should be able to register the new style transforms. And now you can understand why this was quite a difficult thing to do. With so many steps. Now then, it did not quite work. Oh, actually, to be honest, okay, we have two different types of failures here. Okay, that's actually quite interesting. Must say, I wasn't expecting to see a failure of resolution here, given that the type was already working anyway. Think about this for a second. Why would it fail to resolve? Well, actually, to be honest, what we'll do is let's just break the code generator for a second. And let's enable logging. Seems to me that oh, what's peculiar? What model is breaking, I wonder? Okay, this is very strange. Could swear the tests were failing a second ago. Okay, that's not going to help. We clearly forgot to do that. Okay, right, so now let's have a look at it. It might just be that we forgot to get rid of the bugs in our JSON file format. Bit of luck. Okay, so our expectations were met. No, not quite that guy. This guy. Right, so then. That went through quite well. So we could just say something like text.cpp replace legacy smart pointer helper. Okay, we're going to have quite a few entries like this, so it doesn't have to be particularly brilliant. Right, so that worked well. Now you probably noticed that we deleted a whole lot of stuff, including some stitch files. In a second we'll get rid of the whale files, but we need to get rid of every single one of these first. So Well, journey continues. Let's try these guys now. Now, what is probably easier is to make some space somewhere, because we don't really have enough space for all these guys. So I'm just gonna damage my model a little bit. Just ever so slightly. We don't need this for a lot of the time, but just initially. And you can also see there the inserter implementation helper somehow. Something tells me that's going to be a bit special as well. There we are. Well, it doesn't have to be perfect, so we're just going to do this for a few minutes. So what we'll do is we will move these guys to the bottom. This is where copying and pasting would be slightly helpful, because we could just copy all these guys on one go, but nonetheless we probably shouldn't really copy and paste anyway, because it probably will result in even more problems. So what we'll do is, very slowly, we shall handle these guys one at a time. Let's just get an idea of the color. 84C. This is really annoying not having my coloring script. But again, this is just temporary pains. We shall move away from a graphical model at some point in the near future, and then we don't have to worry about colors anymore, or graphical issues of any kind. Right, there we are. So the very first hash helper. So what we now need to do is we now need to say, give us all of these things here. Let's jump over to templates. First thing is just the keys. Now, just have to be a bit careful to make sure we got the right things. So it's always going to be implementation. What is not the same, well, the name clearly is not going to be the same. So whatever we have there, we need that to be date helper. Transform. The family. Okay, so for the family, what we'll do is we'll just jump over to one thing that I'd like to do that I don't think you can in project. Maybe there is a projectile diode. I wonder. There we are. So if I look for test accessibility types, perhaps. Yeah, here we are. I can't believe we even thought about using projectile diode. So in here, there will be a stitch. No, we don't necessarily. Okay, that's because we chose the wrong name. We were doing types for all this time. So we need hash. So there we have the date helper. Now we just grab this guy, and then we need to refactor it slightly. So the refactoring for it will be interesting enough. Notice that the text template key is here, as well as a few parameters. Now we don't actually want this to be the case, and in fact I think this will probably not work. Maybe peculiar, really, isn't it? We could probably get away leaving this as it is until we clean up. I'm actually tempted to see what would happen if I leave it like that, because that would mean I can just copy and paste the template here, paste it just here, press OK, and then just literally delete this chap. And if that's right, I can just do it. No way. It's purely because, okay, there is at least one change that needs to be done. We need to remove the Weld template, because this is relying on the file system. So you see here we are saying stitch.weld template. Now we don't want to say that. What we want to do is we want, in fact, this is not going to work. So sadly we're just going to have to go here. It's not too bad, to be fair. You're just going to have to go here and then update the family, the name, which is done already, and we just have to make sure these guys here match. It's not too onerous, really. And then we remove all these keys. And now that's ready. And then what we need to do is to just take this guy, and I think this may sound a bit overambitious, but I think this will generate the new Weld transform, which it did. Now that's of course not going to compile, we know that already, but we can do a few things. We can convert, we can indent, and we can fix the problem, and now all we need to do is to find the corresponding initializer, which is this guy here, and then all we need to do is to say this guy is now the data helper transform, and hopefully, believe it or not, it is that easy. Okay, right, so there's one more change we need to do to this guy here, which is fine, but it's not too bad. We just, once we got this going, we will remember the set of changes that need to be done. There's a few of these, of course, so it's not super quick, but it's also not the most onerous thing to do in the world. Okay, that's interesting. I thought we would have done enough. Let's have a look now at the generated code. That looks healthy enough to the untrained eye. That too. And that is, I wonder if we need to convert JSON. Right, now let's look at the compilation error again. That should have worked, so... okay, that's fine. Okay, I think this is going to take us a few goes. So this will probably be a data helper transform as well. I thought we'd done a search and replace, but clearly we didn't. OSB mode seems to have re-enabled. Okay. Now then, one more time. Hopefully n time lucky. Of course that won't work, but if we regenerate, then run the tests, now it's going to work. Now we have two options here. We can start committing one at a time. Interesting. Of course we keep forgetting to regenerate at the very end. Suspect this is not going to be the most amazing of videos, because I think we will have a lot of this for a while. Rinse and repeat, I think, because it's going to be basically open up the stitch template, but then again we could do a search and replace. That will help speed things up a little bit. Yeah, I think that's the best we can do, and let's just do it for now anyway. Let's just do a commit at a time. May sound a bit onerous, just add more process, but the reason why is because we're not terribly sure this is all going to work. So replace legacy date helper in hash. We should really say that wasn't types. Okay, so there is the second one, should I say? I'd say the first one, but right, now then, hopefully we'll enter some kind of autopilot. there's the optional helper. Now I wish I could actually just generate a whole lot of these in one go, but I cannot. Now there's nothing of interest here, so I literally can just get rid of that guy first. Then the second step is locating, so this was the optional helper, so optional helper.stitch, locate the stitch template, jump over to this guy here, and now we make sure, okay, that's enabled, so that's fine. The family is optional. This is the optional helper transform, and then here we just do not that. Replace optional helper with optional helper transform. And now hopefully we will have a better ratio success, better hit ratio this time around. So what I'll do this time, just so we don't waste too much time, is I first generate everything. Okay, there's an error. We did something very silly. We forgot one thing. Choose to remove the whale keys. All lessons that we learned in the past. Many of these things were, first time we did this, we didn't do it very cleverly. So for example, we joined, we did sort of a schoolboy error, I guess. At least that would have been, if I was in a professional setup, we would have spotted this as a schoolboy error and not do it. What we did is we joined the two template mechanisms together, which may sound like a great idea, and it did at the time, but what that means is that you can't test them in isolation. Okay, our initializer is the problem now, and I think we just need to run that chap there. Oh, so as you can see, that speed at which we're doing these things has increased a lot already from the first to the third, and that hopefully will just work, which means we can just come here and say optional helper, taking us to the next one. So let's go and grab, it would be very nice to have copying and pasting, of course, because we could get the color automatically done and all sorts of other things, but one must deal with what one has rather than what one wishes to have. It also makes it quite an anticipated thing to move over to the text world, where something like this would literally be a tenth of the time probably. But that's also actually one of the problems. It's quite misleading. If you think of all the refactorings and how much faster things would go if refactorings were in, you'll make the mistake that we did, which is to think that you would delay the refactors until you got to a point where the code is no longer requiring that. So the mistake we did is to say, oh yeah, this will be replaced by a refactor. Oh yeah, this will be replaced by a refactor. And to be honest, it would, in theory, save us a lot of time if we had not had to worry about all this stuff. Because, for example, helpers are to be removed, and the way that the keys are integrating with templates is to be changed, and many things are going to change. Let's see if it generates. Convert. And so what we did is we kept thinking, well, there's no point of touching the legacy helpers because we're going to get rid of it. There's no point of touching the transforms because we're going to get rid of this. And actually, the real world doesn't work like that, because if you accumulate a large number of these should have been placed sort of oh, I thought that's it, right? If you accumulate a lot of these, what should I call them? Refactors that you're never going to do because you know that they are actually not going to be needed at the end. You end up with a code base with about 15 or 10 different refactors that are not done, and then it's no longer reasonable. And by reasonable, I mean you can't reason about your code base anymore, because when you're reasoning, you need to put all these ifs in your head as you're reasoning, and that's a very hard thing to do, as we found out. It's it may sound simple, but actually we kept getting stuck because every time you needed to do a change, we had to say, oh yeah, but remember that this will be replaced, and oh yeah, but remember that's not going to be there, and oh yeah, because this is the ultimate shape for this. And so what would happen is you're trying to make a trivial change, but you'd have to have all these things in consideration, and we just end up with an overflow, really, brain overflow, because the brain couldn't cope with all the conditional state, really. And with time duration, and then that's where we had the moment of enlightenment last sprint, which I probably said about 10 times, where it became obvious that the thing to do actually is to just try to get rid of as many of these intermediate transforms as possible. The reason being that if you don't do that, you think you're saving time, but actually the fact that you're going a quarter of the real speed, if not less, is what dominates really in the time equation. Is the time taken coding that you would have actually been coding, instead of spending time analyzing the ifs and the buts. So there's time duration. What we do, just generate first. Generation works, we then convert, we indent, get rid. So that's why we were so happy on doing the things we did last sprint, really. And there you are, that looks good. So we will just worry about the commit while we wait for the tests. And the tests are green. Right, one thing we should really be doing is make sure we're working off the latest code generator. Now, I'm going to keep this order here just purely for symmetry purposes. Well, actually, to be honest, do we need the symmetry? Probably don't even need that. Right, so as you can see here, we slowly but surely, as you say in Portuguese, paulatinamente, slowly but surely moving across these helpers. This is more the kind of work that you can do with a video, because really you're an autopilot, so it's not so much a problem if you have to talk while coding. That's also where the muscle memory Emacs helps. There was path helper. Still distract a little bit, but it's nowhere near as bad as I say that. Right, so let's do the usual here. Yeah, so I'll talk a little bit about helpers then. Why it is that we created the helpers and why it is that we are going to get rid of them, I guess. So we created the helpers because we had this idea that we could generate models without having any external dependencies. It sounded like a great idea at the time, actually. You would just generate the model, and you wouldn't need to have like a Dogen library that you need to link against. Part of the reason why we thought about it that way was because we didn't really understand model-driven engineering so well. So we didn't understand platform definition models, which is basically a sort of a way to solve the impedance mismatch between existing libraries and your code generator. And what the platform definitions models are supposed to do is they're supposed to expose, in effect, the models for the existing libraries into the code generator. Now we didn't know about that at the time, so it seems very logical to do this. Once you start reading up on platform definition models and that kind of thing, you then realize that actually that's just not scalable. You can't have a helper for every single library. I mean, if you imagine every single library C++ has ever been written, which could possibly expose a type, and that type could potentially be consumed by Dogen, it would be a lot of helpers that have to be built into Dogen. And the other thing to think about is that these helpers, almost always they can be templatized, so there is no binding between the code and the helper, or there is very little binding. It's just more of a concept level binding between the code generator and the code that the code generator generates, and path helper, and the code that the helper has. And so it was that it became quite obvious that really what we should do instead is we should I think we should probably go for the see, this is what I meant about keeping the shape so we don't get confused, but there we are. So it became quite obvious that the only scalable way to do this is to create external models that you would bring in as necessary via references, just like any other model, when we use them. And those external models would have a component that's sort of a component that's the type system for the code generator, but they will also have, potentially, where required, a component that is the glue code that binds the library code against the generator code. And once we saw the world like that, suddenly we realized we were going to have lots and lots of these little products running around. Every time you want to expose a new library, you just make use of one of those guys. And that actually is a much more scalable way to do this. It also means, interestingly enough, that you could test these little PDMs, platform definition models, on isolation. So you could just create a little test that goes along with the templatized method, make sure that it does whatever it says it does, and test that in isolation, have a little build, and away you go. And once you got that, then all of this crazy infrastructure that we got here related to helpers, oops, oh sorry, getting distracted slightly. All this infrastructure that we have related to helpers kind of goes away. Did we not save? Clearly we are not paying as much attention as we should. And so that's kind of where we saw the light, really. And when we saw the light, we immediately said, okay, let's not waste any more time in helpers. Helpers are deprecated, they'll go away. But what we did not do is we didn't replace helpers with PDMs, because we put it on the list of things to do, on the long plan. I mean, if you ever look at the release notes, and you look at our roadmap, which we try to keep up to date, although it's a little bit oracular, as we keep saying. But if you look at the release notes, you see here there's the PDM generation. And really what we wanted was to first get rid of all the formatables, then try to get rid of, well, try to just generate everything from the physical model, then do the PDMs, and then finally start focusing on product generation. I think one step we're missing here actually is we're missing the move to org models, which is probably going to be a sprint in itself. So with this, we tried our best to keep these things going with sort of two worlds. Okay, that's interesting. Okay, let's look at Initializer more carefully. That looks sensible to me, if I'm honest. Where is the linking error? And that's what happens when you stop paying attention. So we must have made a tiny mistake somewhere. I think we did not rename. No, we did. We did rename the method correctly. Let's have a look in Git. So there's the factory, and there's the transform. And well, that looks pretty good to me. Right, this is what tends to happen around here, I'm afraid. Everything's going well, and then suddenly you hit with a problem that makes no sense whatsoever. Right, so what's going on here then? Undefined reference to v table. Okay, let's look at the header, sorry, of the transform in case. So it's the right namespace, right name, and we made a mistake naming the guy. Well, we would have thought the error would be a bit better if it was a name issue, but clearly that looks good. We are including the transform, we are calling apply. What will call the vtable? What will cause the vtable? It's all overrides. There are no virtuals here, but to be fair, let's have a quick look at this guy here. Everything is virtual, so we don't have to worry about the destructor because there is nothing allocated. So okay, I have absolutely no idea why we're failing to link. The interesting thing is, let's look at that initializer slightly more carefully. What is that area 6? Not too sure. Where is that initializer of ours? Right, what did we change? So let's put it in line here. Well, interestingly enough, these things are called transform already. No. Something is not quite right. Right, this is going to be quite tricky to find out. We made a typo somewhere because we were not concentrating. That looks good to me. Right, let's just unstash everything. Unstage. And then stage one at a time. I think that looks good to me. The deletion of that looks good to me too. The deletion of this looks good to me. The deletion of this looks good to me. These models are okay. Now I can't actually look at these because they're not going to show me the diff. So okay, what happened here? The helper.cpp mapped to the helper transform. What's going on here? The helper mapped to the helper transform, but all of the Weld stuff is gone away. So clearly we forgot to add the. See, this is running now. Clearly we should have had a much better error message than linking error. But there you are. We have so much validation that we need to add. That was pretty disastrous. And sadly, this is one of the problems we have at the moment. This code generator is really only useful at the moment as a thesis project, because as an end user you would not be able to deal with all this sort of craziness. It's very, very user unfriendly really, but we will not deal with anything to do with usability until we finish the thesis, because it's a whole world in itself. So you almost need to compartmentalize, I think is the right English word, the work, otherwise you would end up having a never-ending development. What are we doing for time? We have now 12 minutes. So we just wasted a bit of time there. Associative container. I tried to use completion, but I must say I'm not particularly brilliant at it. Right, next then. Let's see if we can do one more or a couple more. Hopefully we're not going to get distracted. You can see clearly what happened there. The productivity just went down significantly just because we stopped focusing and started talking for a second. And you can see just the difference it makes. Because the problem is, once you're not concentrated, you make a mistake, and then even if you then are concentrated to try to figure out that mistake, the mistake is just could be anywhere really, because of the state of the code generator at the moment, with sort of the user unfriendliness of it, which then means that something that could have taken you not that long could then become a task in itself, just the fixing of it. It's a bit disastrous really. But we are hoping that we will improve usability quite dramatically once we move to the once we've finished with all this fundamental work. What should have really happened there for that error is we should have gotten a nice error saying that there were some keys missing or something like that. But I mean, it would not be very user friendly, but it would considerably help, because at least we knew something was missing. But there we go. Now then, hopefully this time we were a little bit more... Oh, we weren't. Oh, we keep forgetting to delete the old world. That I think will be fine. And here we will just take these guys. And then if I just run all tests, usual initializer problem, and hopefully this will compile. Alrighty, so if we now oh, I think we forgot something there, the initializer. And here, this guy was a sequence container. Okay. See how many of these you can do in 10 minutes. How am I doing? You have to be careful with that clock. Actually, we already ran out of time. Righty, so we ran out of time on the variant helper. Probably just stop the video here really, but you get the gist of what we're trying to do. I may actually go away now for a few of these just to see if we can get the bulk of these done. I mean, there's nothing particularly special that you'll be missing. All we'll be doing is exactly what we just did, replacing the legacy ones with this new, still legacy, but more in line with the existing framework kind of format. And once all of these are done, we'll probably turn our attention to C#, do these couple, and at that point the tidy up will start. So let's just call it a day at the moment, and I'll stop clocking as well, because this is a good point to stop. Okay, see you on the next video.